if I have a triangle and I extend the sides so that I have, I don't want arrows on the end. No arrows, don't want to make it green. And I extend each of these sides. So say I extend this side out this way, I extend this side out this way, and I extend this side out this way. And I want to know what is the sum of this angle plus this angle plus this angle. Anyone know what that has to be? It's not 360, it's... oh, it is 360. You're right. Okay. Can anyone tell me why it's 360? Yes, Stephen.
Because it's like 180 inside the triangle, and then they're like opposite angles, so then the second angle, so then it adds up to
Well, so that would be one algebraic way to show that it's true. What do I know about, so what do I know about A plus B plus C? A plus B plus C. You're going to have a little algebraic proof. You're going to like this. This is 180, right? And what if I call this E? What if I call this F? What if I call this G? Right? What happened to D, you may ask? Oh, well, I don't know. But what is B plus E equal to?
B plus E is 180.
180. And what's C plus F equal to?
180.
A equals 180. And what's A plus G equal to? 180. Okay? And so what's, if I added all these things together, I get A plus B, no C, no D, plus C, plus E, plus F, plus G equals how much?
360.
Not 360, I have to add this plus this plus this, right? I'm adding up 540 degrees. I also know from the sum of the angles of a triangle that A plus B plus C equals 180. What could I do with these two things? Very good. Who said that? No. George.
Nice
Sorry,
job.
Sarah. George gave credit for that. Okay. So if I subtract, this goes away, this goes away, this goes away. And I get that E plus F plus G equals 360 degrees. So that's a little algebraic proof of what you guys just kind of thought about. The other thing I can think about is, say this is a skateboarder, right? And he's going down here, and then he goes, oh, I'm going to turn my skateboard this way. And then he gets on this ramp, and he's going down this way, and he turns his skateboard this way. And then he's going down this ramp, and he says, okay, now I'm going to flip and turn this skateboard this way. How many degrees has he turned through all the way around? He's done a 360, you see? He's done a 360. So that is true for that case. If I were to draw a different polygon, okay, say with a, where's my tools? Say drew a hexagon, like this. Let's make a funny looking hexagon. It doesn't have to be regular either. And okay, and I were to extend this side here, extend this side here, extend this side here, extend this side here, extend this side, whoops, should be connected, and extend this side. How much does A plus B plus C plus D plus E plus F have to add up to?
720.
Same thing, right? Because if this is my skateboarder, right, he's going to come down here, move this much. He's going to come down this ramp, move that much. He's going to come down here, move that much. He's going to come here and move that. He's going to come here to here. And then his final tack is going to be over to here. And how much has he gone around? 360 degrees. So that's your first conjecture, says that the sum of the exterior angle, oh, that's on your conjecture sheet. That is C33. I think it says 32 because it says 33 exterior angle. Yeah. Exterior angle sum conjecture. Okay. The sum of the exterior angles exterior angles, and these are called exterior angles. They're an angle formed by extending one of the sides of the triangle. Exterior angles, that should say be one word, not two. I mean 2 words, not one. A polygon one at each vertex, because you can't have more than one exterior angle at a vertex. One at each vertex is 360 degrees. All right? And so, so what I mean by one at each vertex, like I could have another exterior angle going this way, you see, going back here. So now I have 2 exterior angles coming out this side. So you just want one exterior angle coming out each side. And the other thing, if you see a polygon, I want to undo that because it's confusing. Another thing is if you have a polygon, here's another polygon. Let's just say this is another hexagon. And they say find the sum of the exterior angles. If I extend this side this way and this side this way, okay, this thing here is not an exterior angle, right? Okay, this is not an exterior angle. This is an exterior angle. X angle here. How do you tell? By the
It's not the vertical angle?
yeah, it's not the vertical angle because this would be the same as the inside angle. So it's the angle made with a side and by extending the side, with one side and extending the side. So these are an exterior angle. This is an exterior angle. These are the same because these are vertical angles, but this is the same as the interior angle. Okay? Now you can use this to come up with a different formula for each angle. Each, is that how you spell each? No. Each angle in a and this is kind of, I don't think this is on your conjecture sheet. Is it? See, equal angular polygon, you can find the measure of each interior angle of an equal. Oh yeah. So C34, each angle in a regular polygon. There's another. So we already learned this formula, n minus 2 times 180. This is the one that I gave to Will earlier. That's one formula. But another way, sometimes a faster way to do this, is by taking the sum of the exterior angles, 360, okay, and then, whoops, that's wrong. Taking, say I want to find, let's do it by example, okay?
Wait, is this C34?
Yeah, C34. I don't know if this tool works either. I think I have to call the Mobi people. I don't know. But say I know that this angle is 50 degrees. How can I find this angle right there? Julio? How can I find this angle right there? What would it be? What would this angle be right here?
Oh, that's 50, so that would be 130.
130, very good. Okay. Now, if I have a pressure's off. Okay. So now, if I have a regular polygon, say I have a regular pentagon. How do I make a regular pentagon? Pentagon? Where's my pentagon?
Oh,
There's a pentagon. So say this is regular, meaning that all the angles are the same. And I want to find out this angle right here. We'll call it X. Okay? And I could pretend I could extend this side. How much would this have to be?
Depends on how big X is, right?
No, if these are all the same. So this is regular, meaning all the angles and all the sides are the same. So if this is X, how much does this angle have to be? How would I find that angle?
180 minus
No, how many exterior angles are there all the way around? 5, and how many degrees do those have to add up to? 360. So I could go 360 divided by 5, right? That gives me 72 degrees. So how much does this angle have to be over there? 180.
181.
No.
108.
180.
181.
180 minus 72. What's 180 minus 72? 180. I mean 108. So if this angle is 72, then this angle is 108 degrees. So another way I can find the formula for the exterior angles of a regular polygon. Rather, I could also get that by using this formula. N minus 2 times 180 divided by n, but that's a little more complicated than going, sorry, I keep messing up, by going 180 minus, my Mobi is hesitating, 360 divided by n. You see that? So this is another formula for finding each angle of a regular polygon. Hey, pay attention. What? For longer than 11 minutes, maybe. All right. So this formula can be used interchangeably with this formula. I think this one is easier to use. So say I want to know each angle on a regular pentagon. I plug in 5 in here. This gives me 72. And 180 minus 72 gives me this angle right there. Okay? Let's do one more problem. And then, oh, I already did that. How about if I say each, say I gave you a problem like this. Each angle in each exterior angle in a regular polygon is 36 degrees. How many sides does it have? Did you do that? How many sides? What would I do, Manny?
Is it 10?
Yeah, but how do you do it mathematically?
You 360 divided by
360 divided by n equals 36, right? So what's n got to be? 10, right? So you could cross multiply and get 360 equals 36n, and then you just divide both sides by 36, divide by 36, and get n equals 10 times. Is that hard? Easy? Okay. So I think I'm kind of done teaching you here. Okay, so page 263, you can start on your homework. 263, 1 through 11, and number 14. And that's it. Good. And you may start. And I'm going to get back to